Dear students, welcome to Mathematics Online classes. In the exercise 9.3 up to problem number 16, we have completed in the previous session. Now, we will go to the problem number 17. It says, if the 4th, 10th and 16th terms of a geometric progression are x, y and z respectively, prove that x, y, z are in GP. Means I have to prove these three terms x, y and z are in GP. Means ratio between first two terms is same as the ratio between next two terms. That one we are going to prove here. Okay, one geometric progression is given. In that geometric progression, we don't know what is the first term and what is the common ratio. Let us choose. Let first term is equal to a and common ratio is equal to r. They have given that fourth term is x. Fourth term is equal to x. In a geometric progression, what is fourth term? Using the general term an is equal to a into r to the power of n minus 1. Fourth term can be written as a into r to the power of 3, which is equal to x. You can name this as equation 1. And then they are saying 10th term is y. 10th term is equal to 1. What is 10th term? It is a into r to the power of 9, which is equal to equation 2. Next, they are saying 16th term. 16th term is equal to z. What is 16th term? 16th term is a into r raised to 15, which is equal to z. Let me name this as equation 3. See, I will take the ratio to prove that x, y and z are in GP. I have to prove that y by x is equal to z by y. That's all. Because according to the GP definition, ratio should be same. Okay. To prove x, y and z are in GP, let us take y by x is equal to, what is y by x here? Y you say it is a into r to the power of 9 divided by, what is x? X is a into r to the power of 3. A get cancelled. R 9 times r 3 times. Cancel 3 times, we left with 6 times in the numerator. Next, you take the ratio between next two terms, y and z, that is z by y you take. First term is like a2 by a1 and the next term it is like a3 by a2. Z by y, z is a into r to the power of 15 and y is a into r to the power of 9. A get cancelled. Next, these r values are how many times? 15 times in the numerator and r 9 times in the denominator. 9 times we will cancel r. So we left with 6 times in the numerator. You see, a2 by a1 is equal to r to the power of 6. a3 by a2 is also equal to r to the power of 6. That means here we can write, let me take this as equation 4 and this one as 5. From 4 and 5, I have y by x is equal to z by y. This implies x, y, z are in geometric progression. That is about the problem number 17. Now, we will go to the problem number 18. Problem number 18 is that it is a simple problem. Very simple. Find the sum to n terms of the sequence find the sum to n terms of the sequence 8, 88, 888, 8888, so sum to n terms we want. So let us take Sn is equal to sum of n terms is equal to those terms given are 8, 88, 888 plus 8888, so on. It is given. How many terms are there here? Total n terms are there here. Sn is equal to. Now from all these terms, let me take 8 common. 8 if you take out, and here 1 plus 1 1. If you are getting confused in the taking common, what you do? You multiply this back. If you multiply, we should get the original term. 8 into 1, 8. 8 into 11, 88. We are getting it. Means we are taking the common correctly. Next here, 1 1 1, 1 1 1, so on, like this. Again, how many terms are there? Again, n terms are there. Sn is equal to, here what I will do, 8 into, I will multiply by 9 and divide by 9. Multiplying by 9 and dividing by 9, there is no change with that. 1, 11, 111, 1111, so on up to n terms. Next, 8 by 9 you keep as it is. This numerator 9 you multiply with the terms. This becomes 9, 99, 999 plus 9999, so on up to again how many terms? That is n terms. 8 by 9 into this 9 I want to split. 9 I will write as 10 minus 1 plus of, here you can observe one term is getting split into two terms. This 99 I will write 100 minus 1. 100 can be written as 10 square. 10 square minus 1 plus of 999 I can write it as 1000 minus 1. 1000 minus 1 can be written as 10 raised to 3 minus 1. Same way, in the same way we can write up to how many terms? Up to n terms here. I am writing n terms again because I am considering this 10 minus 1 as a single term, 10 square minus 1 as second term, 10 cube minus 1 as third term. Hence, I am writing it as n terms. If you consider this as one term, this as second term, you should write 2n terms here. Now, let me split this sequence. 8 by 9 into this 10, 10 square, 10 cube, I will write once. 10 plus 10 square plus 10 cube, so on. These are again n terms. And now, from each term, one term will be separated, that is minus 1, minus 1, minus 1, minus 1. Minus 1, minus 1, now if you take minus common there, 1 plus 1 plus 1, how many times it is? Again it is, n terms are there here. 8 by 9 into, okay, here you can use GP. This one you observe, 10, 10 square, 10 cube, it is in GP, in geometric progression. With A is equal to, first term is equal to 10. What about the common ratio? Common ratio R is equal to A2 by A1, 10 square by 10. One time 10 cancels. R is equal to 10. And what about the Sn? Sn is equal to 3 formula we have. Which one to use in that? R value you observe, R value is 10. Means more than 1. When R value is more than 1, you use the formula Sn is equal to A into R to the power n minus 1 by R minus 1. Okay. What about this? 1 is getting added n times. We will write that one as n. That's all. 8 by 9 into, yes, according to this formula, 10 into 10 to the power of n minus 1 by 10 minus 1. Minus of 1 if you add n times, that becomes n. Okay. 8 by 9 outside you keep it as it is. 10 into 10 to the power of n minus 1 by 10 minus 1 is 9 minus n. This is the required answer. Problem number 18 completed. Now we will go to the problem number 19. Problem number 19 is that find the sum of the products of the corresponding terms of the sequences 2, 4, 8, 16, 32 and 128, 32, 8, 2, 1 by 2. Here two sequences are given to us. In each sequence 5 terms are there. First sequence is that 2, 4, 8, 16 and 32, and second sequence is that 128, 32, 8, 2 and 1 by 2. Sum of products of corresponding terms I have to calculate. Sum of products of corresponding terms. First of all, what we have to do? We have to take the product of corresponding terms. Product of corresponding terms. Product of corresponding terms is 2 into 128, 4 into 32, 8 into 8, 16 into 2, next 32 into 1 by 2. These are the corresponding terms. It's a sum I have to take. Sum Sn is equal to, here 5 terms are there, simply I can write S is equal to, sum S is equal to 2 into 128 plus 4 into 32 plus 8 into 8 plus 16 into 2 plus 32 into 1 by 2. Let me simplify here. 2 into, I will take the common, hence I will write one more step here. 2 into 128 plus 4 into 32, 8 into 8, I will write 64. Next here 16 into 2, I will write 32 plus of 32 into 1 by 2. Now from all these 5 terms, what is common? I will take 32 common here. If 32 is taken common, then here it is 32 fours are 128. Hence 2 into 4 remains here. 32 I am taking common. Next 32 is outside, only 4 remains here. 64 can be written as 32 into 2. 32 is already outside, here only 2 remains. Next here 32 into 1 remains. 32 is taken common. 32 is taken common means 1 by 2 remains here. Fine. This is 32 into 8 plus 4 plus 2 plus 1 plus 1 by 2. Now we can go with the formula. This series you observe, it is geometric series. Hence A is equal to 8, common ratio R is equal to 4 by 8 means 1 by 2. How many terms are there? N is equal to 5 terms. 1, 2, 3, 4, 5. N is equal to 5 terms are there. R value is less than 1. So use the formula Sn is equal to A into 1 minus R to the power N by 1 minus R. Or else directly you take the common here, nothing, no problem. Directly you take the common. 8 plus 4, 12. 12 plus 2, 14. 14 plus 1, 15. 15 plus half. Like that you take. No problem. 32 into, I am using this formula, 8 into 1 minus of R is 1 by 2. 1 by 2 to the power of 5 divided by 1 minus 1 by 2. 32 into 8 into 1 minus of 1 by 2 to the power of 5 means it is 32 divided by 1 minus half is half. Thirty-two into That 2 will come to the numerator. 2 into 8. If you cross multiply that, 32 minus 1 by 32. 32 get cancels. 2 into 8 into 32 minus 1 is a 31. This is, you enter in the calculator, 2 into 8 into 31. Answer 496. This is about problem number 19. Now we will go to the problem number 20. Problem number 20 says, show that the products of the corresponding terms of the sequences A, AR, AR square, so on up to A into R to the power of n minus 1, and capital A, AR, AR square, so on up to A into R to the power of n minus 1 form a GP, geometric progression, and find the common ratio, See, here two GPs are given to us. First geometric progression is A, AR, AR square up to A into R to the power of n minus 1, where small letters are used. And here second GP, A, AR, AR square, capital letters are used. Two GPs are given. They are asking you to show that products of corresponding terms of the sequences. Products of corresponding terms are what are those? Here first term A is there and this is A, that is nothing but A into A. Next, second one is AR into AR. Third term is AR square into AR square. So it goes like this. And last term is A into R to the power of n minus 1 into A into R to the power of n minus 1. We need to show that this forms a GP. ಈ ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಟರ್ಮ್ಸ್ಗಳನ್ನ ನೀವು ತಗೊಂಡಿರಲ್ರಿ, ಪ್ರಾಡಕ್ಟ್ ಆಫ್ ಟರ್ಮ್ಸ್ಗಳನ್ನ ತಗೊಂಡಿರ್ತಕ್ಕಂಥದ್ದು GP ಆಗ್ತತಿ ಅಂತ ತೋರಿಸ್ರಿ ಅಂತ ಇಲ್ಲಿ ಕ್ವಶನ್. You take the ratio between first two terms. R is equal to A2 by A1. A2 is AR into AR. A1 is A into A. This AA get cancels. We left with R into R. Next, you take the ratio between third term and second term, that is A2 by A1. A3 by A2. A3 is A into R square divided by A2 is AR into AR. AA get cancels and R, one time R also get cancels. We left with the R into R only. Like that you take the difference, ratio between any two consecutive terms. That will be R into R only. Let me take the last term, that is, this is nth term. Nth term by A of n minus 1th term also you can take. That will be again A into R to the power of n minus 1 into A into R to the power of n minus 1. What will be its previous term? N minus 1th term will be A into R to the power of n minus 2 into A into R to the power of n minus 2. AA get cancels. This one we will be having R to the power of n minus 1 into R to the power of n minus 1 divided by R to the power of n minus 2 into R to the power of n minus 2. These are like A raised to m by A raised to m, nothing but A raised to m minus m. I can write here R to the power of n minus 1 minus of n minus 2 into R to the power of n minus 1 minus of n minus 2. Here you see r to the power of n minus 1 minus n plus 2 into r to the power of n minus 1 minus n plus 2. N get cancelled. Minus 1 plus 2 means r to the power of 1 it is. Here also r to the power of 1. R into r only we are getting. Like that you take any ratios between any two consecutive terms, that will be same. Therefore, the corresponding terms, products of corresponding terms. Therefore, the products of the corresponding terms, products of corresponding terms of the sequences forms a geometric progression. That one we can conclude. Now, second is that find the common ratio. What is the common ratio we are getting here? Ratio between any two consecutive terms, that is r into r. Common ratio is equal to r is equal to a2 by a1. a2 is ar into ar. a1 is a into a. A get cancels. We have r into r. This is about problem number 20. Now we will go to the next question, that is problem number 21. Problem number 21 is find four numbers. Find four numbers forming a geometric progression. In which the third term is greater than the first term by 9, and the second term is greater than the fourth by 18. See, question is saying that find four numbers forming a GP. 4 ನಂಬರ್ಗಳನ್ನ ಕಂಡುಹಿಡಿಯಿರಿ, ಅವು GP ಮಾಡ್ತಿರಬೇಕು, ಅವು GP ಅಲ್ಲಿ ಇರಬೇಕು. In which third term is greater than the first term by 9. ಮೂರನೆಯ ಪದ ಒಂದನೆಯ ಪದಕ್ಕಿಂತಲೂ 9ರಷ್ಟು ದೊಡ್ಡದಾಗಿದೆ ಅಂತ ಅರ್ಥ. And the second term is greater than the fourth by 18. Okay, it is given third term is means we put equal to greater than the first term by how many times? By 9. And the second term is greater than the fourth term by how many times? By 18. We have to find out first find four numbers forming a GP. 4 ನಂಬರ್ಗಳನ್ನ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಬೇಕು. Okay, very easy it is. Third term of a geometric progression we will write here. Third term of a geometric progression is that a into r square, which is equal to first term is a plus 9. Take this to the left hand side. ar square minus a is equal to 9. Let me take this as equation 1. Next, second term. What is that second term? Second term is a into r, which is equal to Fourth term is a into r cube plus 18. Take this to left hand side. ar minus ar cube is equal to 18. This is equation 2. And then what are the first four terms here? First four numbers are a, ar square and ar cube, because they have to form the GP. That's why. Now a and r values are needed. For that, what you do? You need to solve for equation 1 and 2. So taking equation 1 by equation 2. Equation 1 is ar square minus a, and here equation 2 is ar minus ar cube, which is equal to 9 by 18 in the right hand side. You take common here. A is common. We left with r square minus 1. In denominator also, to have r square minus 1, you take minus ar common. If you take minus ar